Welcome to this episode of Conversations About Geology. I'm your host, Professor Gilbert Bernhardt. Today we explore three important escarpments across the Texas coastal plain, the Catahoula, Oakville, and Bordas, and the geologic story they tell. An escarpment or cuesta forms where erosion cuts into tilted sedimentary layers, exposing the edge of a resistant rock bed above softer underlying strata. This geometry produces two contrasting slopes, a steep scarp slope on the up-dip side and a gentle dip slope facing in the direction of the bed's dip. Because the formations of the Texas coastal plain dip gently towards the Gulf of Mexico, the steep faces of the Catahoula, Oakville, and Bordas escarpments actually face inland, not seaward. Their gently inclined dip slopes descend towards the modern coast. This cuesta geometry is one of the defining characteristics of the Texas coastal plains landscape evolution. All three escarpments are found within the intercoastal plain or on the border between the intercoastal plain and the coastal prairie, and run approximately equidistant and parallel to the modern coastal shoreline. If you're driving across Texas, the Catahoula escarpment is viewable while driving on US 290 west of Brenham, on IH-45 between Huntsville and Madisonville, and on US 69 between Woodville and Lufkin. The Oakville escarpment is viewable while driving on IH-10 between Columbus and Luling near Texas Highway 304, on US 183 between Cuero and Gonzales and near Three Rivers, on IH-37 between Corpus Christi and San Antonio. The Bordas escarpment is viewable on State Highway 359 between Hebronville and Laredo, or on US 83 between McAllen and Laredo, south of Falcon Reservoir near Escarpments. The Texas coastal plain is built from a thick wedge of Cenozoic sediments that gently dip towards the Gulf of Mexico. Over millions of years, rivers delivered sand, silt, and clay to this passive margin, while volcanic ash occasionally blanketed the region. As resistant sandstones accumulated above softer mudstones, erosion carved out a repeating pattern of cuestas and escarpments. The Catahoula, Oakville, and Bordas escarpments form a steep sequence of geomorphic belts marking different phases of coastal plain evolution. The Catahoula formation formed 25 to 30 million years ago when broad river systems crossed Texas. The Catahoula is a mixed fluvial, volcaniclastic sequence consisting of weakly cemented and cross-bedded ash-rich, medium to fine grain, tufaceous sandstones, with lenses and inner beds of volcanic ash, altered to smectite and kaolinite, clay and silt units forming recessive slopes, channel-filled sandstones and conglomerates forming resistant benches or escarpment facies, and paleosols. Sediment originated from volcanic terrains of the Trans-Pecos and Sierra Madre Oriental, as well as from older coastal plain deposits. Ash from the Sierra Madre Occidental, one of Earth's largest ignimbrite provinces, blanketed Texas during the Oligocene. Ash also arrived from the Davis Mountains and Trans-Pecos region. As this material weathered, it produced smectitic and kaolinitic clays that underlie resistant sands. This contrast plays a key role in shaping the Catahoula escarpment. The lower Miocene Oakville Formation is comprised of interbedded sandstone and clay. The sandstone is medium grain, calcareous, light yellowish gray to light gray, thick-bedded with some cross-bedding. Locally contains fossil wood, quartz, and chert pebbles, vertebrate fossils, and reworked Cretaceous invertebrate fossils. The clay is calcareous and yellowish gray. The clay weathers away more quickly, creating lower, rounded slopes. Because the formation tilts slightly towards the Gulf, the top of the sandstone becomes the gentle dip slope, while the edge of the sandstone creates the steeper inland-facing scarp. This contrast between resistant sandstone and weaker clay is what produces the Oakville Escarpment's distinctive topography. During the Miocene, sediment supplies surged as rivers tapped the Rockies, the Great Plains, and the Cretaceous sediments of central Texas. These systems transported quartz-rich sands deep into Texas and onto the coastal plains. The Oakville Formation consists of thick, laterally extensive fluvial sandstone bodies that are far more resistant than the Catahoula strata beneath them. This creates the prominent Oakville escarpment that is higher, sharper, and more continuous than the Catahoula escarpment to the north and east. The Bordas escarpment is a late Miocene cuesta developed on the Goliad Formation, a fluvial deltaic sedimentary unit that is younger and more gulfward than the Oakville Formation. During the late Miocene, the Gulf coastal plain was experiencing 1. A high sedimentation rates from rejuvenated stream systems draining the Edwards Plateau, central Texas uplands, and older Miocene units. 2. Prograding fluvial deltaic environments that were moving steadily gulfward. And 3. The reworking of older formations such as Oakville, Catahoula, and even older Eocene units. The Bordas escarpment exhibits low to moderate relief, rounded hills, and broad uplands, subtle but definable inland-facing scarp, dip slope extending southeastward, local benches from calcareous or ferruginous cemented layers, and finally, deep soils and gentle drainage divides. Although less dramatic than the Oakville escarpment, it is clearly visible in shaded relief maps and as a break and slope on the South Texas surface. The Goliad Formation is moderately permeable where it is sandy. It is important for recharge in South Texas, provides a reliable shallow aquifer, and influences regional groundwater flow patterns. These three escarpments collectively reveal the geologic history of southeast Texas by showing river system evolution, the impact of distant volcanic events, and how differences in rock strength shape the landscape. They also influence regional groundwater flow and host environments favorable for uranium mineralization, particularly in the Catahoula Formation. The Catahoula, Oakville, and Bordas escarpments trace a long transition from ash-rich Oligocene systems to sand-rich Miocene rivers to younger sediments near the modern Gulf. Their subtle but persistent forms remind us that the Texas coastal plain is a living archive of ancient rivers, volcanism, shoreline migration, and erosion. This video was written, produced, and hosted by Professor Gilbert Bernhardt. The music for the video is Gymnopédie No. 1, composed by Eric Satie and performed by Clara Carmendi.